Hello everyone, yeah, welcome to Boy tutorial. The topic of this video is set. So if you are new to my channel, make sure you subscribe and also like this video. If there's any problem, you can comment on the comment box. Right. Topic to cover on this video. Topics to cover. One, we are going to define a set. Two, we are going to represent sets in various forms. 3, we are going to state various types of sets. Then 4, we are going to perform some basic operations. Then 5, then we use Venn diagram to solve some problems. Alright, so these are what we are going to cover in this video. Okay, now let's define set. Set. A set is a collection of elements by well defined rule. For example, we have sets of spoons, we have sets of plates, we have set of plates, sorry, sets. We have set of plates, we have sets of spoon, and we also have like okay, and many others like that. So we have like bunch of banana, and all these are sets. Now you have to note this. You have okay, note a set donated is denoted. A set is denoted by capital letters, that is uppercase letters. Why its element? Why the element is denoted by lowercase letters. Why we go further, you understand why I have to list this down. Let's do the state representation. Set representation. Set can be represented in a one in a tabular form. Two, we have the set builder form, and three, thirdly, we have the Venn diagram. These are the three ways sets can be represented. Now, let me explain more. For the tabular form, it looks like this. So these are in tabular form. For set builder form, it looks like this. Using this for instance, it's going to be so this is for the set of A. Also for set of B. Alright, let me first of all explain what this actually means for set of A. Now for set of A, it means A is a set of X, comma, such that X, which is this X, is alright. I made a mistake. This is not how it's going to be represented. This is not how it's going to be represented. It's like this. So this is the best way. One, so that one, now not X, one is less than or equal to X, and X is less than or equal to 4. So that's the meaning for of this. A is a set of X such that 1 is less than or equal to X, or X, and X is what, less than or equal to 4. So that's the meaning of this. Now for this other one, it's going to be B is equal to X such that X is an even number less than or equal to 8. So that's the meaning of this in set builder form when you want to represent this from the tabular form to the set builder form is going to be in this form. Now let's go to Venn diagram. For a Venn diagram, always come with a box. Um, Circles in between. And we have a universal. Universal is the total amount of everything here in this box. All the numbers in this box makes up the universal, this U. So I'm going to explain more on this Venn diagram. So make sure you watch this video to the end. And if you are new to this channel, please make sure you subscribe. Alright. So let's go to types of sets. Remember, we have various types of sets. We have the universal, which I just explained. Is a set that contains all the elements or subsets. These are subsets of this set. A is a subset of this branch of circle. B is a subset of this branch of circle. C is a subset of this branch of circle. So all these branches, even the void that is outside here, or as long as they are in this box, they are all universal sets. So that is what I mean. It is a set that contains all the elements of subsets. Now, what is subset? This is your number one type of set. Number two, okay, before I explain more about this set, I would love to draw my table. This is my table. Um, Therefore, our universal set, our universal set for this table, which is the U, is going to be 1, 2, 1, 2, 3, 4, 5. Which equal at number D we have 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 1, 2, 3, 4, 5, 6, 7, and 8, because everything here is also in A. So all the elements in C are also in D. Some elements in C are also in D, but except 10 and 12. Then the letters A, B, C, D, and E. I close my bracket. All these are the universals. They are all the elements. Now, for my subsets, I can say A, B, C, and D are the subsets of U because contain all the elements. They are all under U. Then I can also say that A is a subset of D because all the letters, all the numbers in A 1, 2, 3, 4, 5, also in D 1, 2, 3, 4, 5. So A is a subset of D. Therefore, we have different kind of subsets. We have the superset, proper set, sorry. We have the proper set and we have the superset. So for the proper set, for the proper subset, because it's under subset, for the proper subset, it has a symbol like this, like a C, and we can say that A is a proper subset of D. So if A is a proper subset of D, therefore we can say for superset and super subset, we can see that okay, super subset has a symbol like this. If this is facing this way, so that one is facing this way, like greater than and less than. So we are going to say D is a super subset of A. Understand? So if it's for the universe is a super subset of A, A, B, and C. And also we can say that the universal is a super subset of A, B, C, and also D here from this table. So that's different between the universal set and this subset. Now let's go to number 3 types of sets. We have is the equivalence. The equivalent sets. They are same in numbers, but not in kind. They are same in numbers, but not in kind. And it also have a symbol. Now, this is symbol of the symbol is 1, 2, 3. That is 3 slash. Understand? So if they are not equivalent, then it's going to be 1, 2, 3. Then you cut it off. So this means not equivalent. Then this means is equivalent. All right. No, now let me use this my table to show you equivalent. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Remember, they are not, what did I say? Same in numbers, but not in kind. Now, this is 1 and this is A. So they are not in kind, but they are same in numbers. When you want to number them, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So therefore, we can say A is equivalent to B. Understand? Yeah. But we can also say A is not equivalent to C. If you count it, this is 5. 1, 2, 3, 4, 5, 6. So A is not equivalent to C, and also A is not equivalent to D. It's only equivalent to B because they have the same numbers, all right, but not the same kind. Okay. Now we have also another one called the equal set. That's for number 4. Equal set. Now for the equal set, they are same in numbers and also in kind. They are same in numbers and also in kind. In this table, we don't have equal sets here. So I'm going to bring example of equal sets. For instance, I bring A. Let A be A, B, C, D, and E. I close. Then my B will be like B, A, C, E, and then D. All right. Now, if you look at these two, I have A here and also have A here. I have B and also have B here. I have C, also have C here. I have D, also have D. E, also have E. Now, if you count it, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So they are the same in numbers and also in kind. That's what make this equal set. They are different from the equivalent. Equivalent, sorry. So we can say A is equal to B. So this is a symbol for equal set. But once it's not equal, there is a symbol it has. You have to cross it. So this means it's not equal. For instance, I can say A is not equal to B. A here is not equal to B because this one, this is a letter, this is a letter, and this is a number. So they are not equal. And also A is not equal to C because these are even numbers. These are even numbers. There is one here and you can't find one in C. And there's two here, you can find two. You can find three here and so on. So A is not equal to C and C is 6. A is 5. Then A is not equal to D because D continues. D is more than 5. So it's up to 8 and A is 5. So A is not equal to D. So I can say A is not equal to D and also A is not equal to C 2. So that's for that.